All right, it's a new day, right? All right, so unit 7, exponential decay and growth is our first lesson. Okay, this unit we're talking about exponentials and logarithms. So there's going to be things that I tell you today that you have to remember, either study or I'll give you some hints to remember them. And then we do logs next class, there'll be things as well that you need to know. So first, graphs that have x as the exponent, such as y equals a times b to the power of x, are called exponential functions. Exponential functions. What I like to think about, you can just underline this if you don't have another highlighter. If I have an x in the exponent, it is called exponential. Do you see those play on words of just x? There's an x in the exponent, it's an exponential graph. Okay? Exponential functions have a horizontal asymptote. We learned about asymptotes last unit. For this lesson, we're only doing horizontal asymptotes. A horizontal asymptote's left to right or up and down. It's horizontal. This way, right? You're thinking about your y-axis. The y-axis goes up and down, but horizontal means we're going left to right. All right, so if your b, the b is basically what's attached. If you look at this equation, y equals a times b times x, or the power of x, your b is whatever is attached to your exponent. If you have a b that is larger than 1, it goes away from the asymptote, and we call that a growth. If our b is smaller than 1, it goes towards the asymptote, and we call that a decay. That is a very big part of this lesson. Our mini quiz will ask you, how do you know if it's a growth or decay? This is basically how I learned it, okay? I think about the words, because I'll say this all day today. Away, okay, write this on your paper. Away makes me think about grow. They're both 4-letter words, and they both have W's. It's not the greatest thing to remember, but that's how I remember it. I think about, am I going away or towards it? If I'm going away, I think about that W, I am growing. So it is a growth. Okay? What I also think about is in the word towards, which means going towards something, like you're getting closer to it. It is a decay. And the letter that sticks out to me in this is the letter D, because decay starts with the letter D. So if you think about towards, it has a D in it, so does decay. The more we do this, which is kind of like 50% of our lesson today, the more you'll get it. Forgot the PE class since we're back outside. All right, so let's look here. Okay, we have, your example is y equals 2 to the power of x. For this lesson, guys, you absolutely have to use your calculator. I don't want you to sit there and wait for the next person to try it, and then you wait for them to answer. You guys have to practice this stuff because you may mess up at least once, which is perfectly okay. This is all new. But there's certain ways to type these problems in. All right, so everyone in here has one of the older calculators, so I'm going to switch my calculator. Okay. I want you guys to type in 2 to the power of x. So 2 to the power of x. This one's kind of harder to see. All right, sorry, I'm switching back. I'll just tell you what you need to do. because I want you guys to really see what I'm typing in. This one, you know how they have those flatter calculators?
Yeah.
The new TIs? That's what this one, like this one has that software. The one before that I was using, look at the one that you have. This one has the plus C. I think yours just says TA4 plus. Okay, this has the C with it. All right, once you do that, you have 2 to the power of X. Go ahead and graph it to see what it looks like. Make sure that your graph looks like my graph. If it doesn't, we have a major problem. Okay, I need the calculator, Jeremy? Go ahead and get one. Okay, so everyone's looks like that, right? It looks like my asymptote is at this line right here at 0. I'm going to teach you in a little bit how to find that, but first, let's hit second table and let's get some points. Huh? It doesn't?
No, I mean, we get the same, we did this show like the graph. It's a little bit longer.
Hit zoom 6. That change it a little bit?
No, it's just top
See yours?
it's 2x.
Oh yeah, this is fine. Yours doesn't really show where it overlaps there. That's the only problem. Just have to imagine that it is. Alright, so at my table, I want you to look at your table on your calculator. I have, I'm going to find points for -2, -1, 0, 1, and 2. For -2, what's your Y value?
0.25.
0.25. What about -1? Good. What about 0? What about 1? And 2 is 4. Okay? For the sake of just this lesson, my asymptote, which I want you guys to draw with just a dotted line, your asymptote is going to be at 0. So make that dotted line. Someone asked earlier if he had to do it. The answer is yes. You have to draw your asymptote. It actually makes your life a lot easier. All right, let's plot these points. We always start at the origin, 0, 0. So from negative, the first one is -2.25. When we have to graph decimals, try to get as close as you can. Okay? So -2.25 is going to be barely above my 0. -1.5. 0, 1. My board's a little off. 1, 2. And 2, 4. So I'm going to try to get as close to my asymptote as I can. And we're matching it with what my graph shows. All right, so here's the big question. We always start from left to right when we have these graphs, okay? Always, always, always. From left to right, look at my hand. Am I going away or towards the asymptote? Going towards it?
Away.
I'm going away from it. Do we all see how I'm going away? Okay, I started here. There's my asymptote. I'm going away from it. So, will it be a growth or decay?
Growth.
It will be a growth. Another way we can find that out without doing the whole hand thing is to look at your number that is attached to your exponent. Is my 2 bigger than 1? Yes, so because 2 is bigger than 1, then it's a growth. Okay, if this number attached to your exponent is bigger than 1, it grows. If it's smaller than 1, it decays. All right, let's look at number 2. Grab your calculators. Go to your y equals. We have 1/3 to the power of x. I'm going to put 1/3 in parentheses to the power of x. Okay. Let's graph it to see what it may look like. Make sure that yours looks like mine. Is that what yours looks like? Okay. Let's Let's go to our table. Clearly, I am not going to try to graph negative 327. My grid is only like 10 by 10. I can't even get 27. So I'm going to start at negative 2. So my graph here, let's go negative 2, negative 1, 0, 1, 2. For negative 2, I saw that my y value was 9. What about for negative 1?
Negative 3.
3. What about 0?
1.
And 1?
1, 7.
0.3 repeating. And what about 2?
1.
0.1 repeating.
Yeah.
You can just show it like that. I'm not too concerned about your decimals. Just try to, if it's 0.5, then put it in the middle. If it's less than 0.5, you go lower. If it's higher than 0.5, you go higher than that. For the sake of this lesson, my asymptote is going to be 0. I'll explain that more in a little bit.
I could leave right now. Nobody cares.
All right, let's plot these points. Negative 2, 9. Negative 1, 3. 0, 1. 1.3, and the decimal, I'm just going to try to get really close to my 0. All right, let's take a look. Once you graph it, if I start from left to right, am I going away or towards my asymptote? You're going towards the asymptote. You see that? I think you see that? Jeremy, you got it. Okay, so will I grow or decay?
Okay.
We're going to decay. Good. I want you guys to answer number 3 and 4. Take a look at it. There's nothing really to do. We have to decide whether to growth or decay. I always go from left to right. So from left to right, am I going away or towards it? Away, so that would be?
Okay.
No, away is growth.
Oh, wait. That's one from myself.
Yeah, it's the air pressure and all that. That one was rough though. All right, example 4, from left to right, we always start with left. Away or towards? Towards, so it's going to be
Okay.
decay. The only time I see someone mess up on this is if they go left to right. Right to left. If you go from like the bottom up, well, of course it's going to look like it's going towards it, so you may write decay. Make sure you always start with your left side. All right, turn the page. All right, this part we have seen before. We're just going to apply it in a different way. We have this A. Okay, A can tell me 3 things, depending on what it is. Let's say there is a negative in front of my A. That's going to tell me to do what? What does a negative tell me to do?
5 seconds of walking, I'm like, I don't know about outdoors.
I know. Well, yeah, this door just slammed. I was like,
I'm thinking like door front.
Yes, I agree. All right, who remembers what this is?
Minus.
A minus or a negative out front can tell my graph to do what? Flip or reflect. Good. You can write either word here. I don't care.
I'm gonna do a minus.
Huh?
You can just slam the
Alright, so now let's say, what if this A is bigger than 1? Will I stretch or will I compress? Good. You're going to stretch. Okay, and what if it is less than 1? You compress. We have done transformation since Unit 1. We apply it to different equations, but you guys have to understand that. What's that noise? Did I hear that? I think it's me. next door. Alright, look at letter B. This one is a little new for you because we just started it. Your B is attached to your exponent. If it is greater than 1, we are going to have a growth. So therefore, if it's less than 1, then what? You are going to decay. You guys know what decay means, right? You went psychology, from biology? Yeah. Get smaller, kind of wither away. This H here, we've only had an H when it was like in parentheses or something. So that can tell me two things. What if it's a minus sign? Which way do I go? Nope. That's the last one.
Oh, left.
Left or right. So if it's a minus, it goes right. I know it goes right because I've taught myself that that minus sign is like crossing the T. That's just how I remember it. And if it's a plus sign, which way do we go? Left. Good. I know it's left because it looks like I have two plus signs in my F and my T. Lastly, we have K. This K can tell me two things. What if it's a minus? Which way does it go if it's minus? It goes down. And if it's positive, it goes up. All right. Your horizontal asymptote, this is important, is y equals 0. Wait, don't write that down. I'm sorry. Oh, sorry. I just tainted your brains. Y equals k. What that means is your horizontal asymptote is going to be this last number after your exponent. What if there's nothing there? It's 0. That's what I was thinking of. If there's nothing there, it's assumed to be 0. If we have a number after our exponent, whatever that may be, then you keep that same number. All right, your domain will always be negative infinity to positive infinity because we have arrows and we're going from left to right forever and ever. And for your range, we always start at the bottom and we go up. My range is going to be k to infinity or negative infinity to k. Mind you, your k is basically your horizontal asymptote. Okay? Alright, look at example 5. I want you to grab your calculators. Clear it out. Let's type this in. For this one, your exponent, you must put in parentheses. So I have 4 times 2 to the power, so use your caret key. And I want you to do parentheses x minus 3, close parentheses. If you don't put your exponent in parentheses, your answer will be completely different and wrong. Let me know if you have this graph. You guys do? All right, sweet. So I'm going to plug in a few things. So let's see, I'm going to put in my x values of 0, 1, 2, 3, and 4. So I'm going to look at your table. For 0, what do you have for your y value? Good. What about 1? 2, 3, and 4. 8. Before we even do anything, everyone look up here. Do I have a number after my exponent? No. So that might as well be plus 0. So what is your horizontal asymptote? 0. Good. So grab your pencil or your pen and draw a dotted line horizontally for 0. I like to always put my asymptote there first and then start plotting my points. So I have 0.5. Well, I'll go to my 0. I go up 0.5, which is basically right in between 0 and 1. 1, 1. 2, 2. 3, 4. And 4, 8. And I'm going to draw, granted, once again, my board is a little off. Try to not get below your asymptote. Mine did a little bit, but we're just sketching the graph. Is that a movie next door?
The other one.
Alright, so, here's your famous question. Chinny, from left to right, am I going away or towards my asymptote? We're going away. So therefore, do I have a growth or decay? You have a growth. We're all on the same page with that, right? From left to right, I can clearly see that I'm going away from my asymptote. Alright? My domain is going to be negative infinity to positive infinity. I go left and right, on and on and on. I'm gonna just, my curve just keeps going. Jeffrey, write this down.
Yeah.
Alright, my range from down to up. Where does my graph start? At the asymptote. What is my asymptote?
0.
0, and I go up towards positive infinity. Huh? Y-intercept, you can do this a couple of ways. You're looking for where your graph crosses your y-axis. I just like to look at my table for where is x 0. 0.5. Or you can write y equals 0.5. If you don't want to write the point, you have to write y equals. You cannot just write a number. That does not work. Any questions on number 5? All right, you guys take a second, and I want you to do number 6. I will get you started a little bit with your points. You guys go ahead and graph it, and I'll wait. Make sure you put your exponent in parentheses. Once again, you can always pick whatever points you want. You don't have to pick points that I pick. I just try to get at least 4 or 5 easy ones. Sometimes they're not all easy. Sometimes they're decimals, but. Anyone have the y value for negative 3?
Negative 3. 3.5.
You should get 3.5. What about for negative 2?
Yeah.
And negative 1? And 0. Did everyone get these points?
No.
No?
Somehow I guess I need all my identity for that.
Alright, so just from looking at this, what is my horizontal asymptote? Good, positive 3. Jeffrey got that from our last number after our exponents. Go ahead and write that in. And if I were you, I would go ahead and I would go to draw my horizontal asymptote at positive 3. Alright, I'll plot my points. Alright, that's what your graph should look like. I said do this on your own, but now that we were kind of almost done, someone give me some answers. Is this a growth or decay? How do we know? We're going away from my asymptote, so we are growing. My domain, my range, well, kinda. Oh yeah, you're right. If I start from down to up, my graph is starting at not -3, +3. Is that what you said?
Yeah.
Sorry. +3 up until infinity. My y-intercept? Nope.
7.
Your y-intercept, where's your x? 0.
Also.
0, 7. Or you can write y equals 7. All right, your transformations. I want you guys to look at what is different from my original function, which is y equals 2 to the power of x, to my new function of y equals 2 to the power of x minus 2 plus 4. What is new in my new equation?
The 2 and the 4.
The positive 2 or the negative?
Negative.
The negative 2 is new. What else?
2.
The plus 4. All right, so I have 2 transformations then. My first transformation is what? How do I show -2? And when it's in this space right here. Look back at your notes. Look at your transformation. It's negative. We're going to go right to, because that is a -2. What does that +2, the +4 tell me to do? Of how many? I think we're only reflecting when my negative is in front of my A, which is in the very beginning. Look at your second problem, example 8. What is new?
Example 8.
The
+1.
+1, what else?
-2.
There's one more. It's hard to see. The minus in front. So I have 3 transformations. This negative that's in the very front tells me to reflect. What does this +1 tell me? Good. We're going to go left 1. What is this -2 at the very back? Perfect. Okay. Are we all good? All right, we got to keep moving. All right, E is an irrational number, which is approximately 2.718. That is not too important today, but it will be in a little bit. The way that we find our E is on the calculator. It is second ln, which is right beside the number 4. I'll show you in a second. Let me know when you guys are done with this one.
What's another time?
Kinda. All right, number 9. For the sake of time, I'm going to go ahead and give you the points, so you don't have to type them in. Oh wait, I can't do that. Grab your calculators really quickly. Go to your y equals, so you can see how to type this in. All right, we have y equals e to the power of x. Your e is hit the second key, and then ln, which is right next to 4. So second ln. You guys got it? And then to the power of x. So your graph will still look like this. Okay? So, your horizontal asymptote If you look at your equation, is there anything back here? No, so y equals 0. Draw your dotted line for your horizontal asymptote. My points are not going to be exact. Let me pull up my graph. All right, that's what it looks like. So I'm basically, I have to go through 0, 1. Our graph looks something like that, right? Growth or decay? Growth, because I'm going away from the asymptote. My domain. My range. 0 to positive infinity. And my y-intercept is 0, 1. You guys got that one? I have 4 minutes to show you the last one. We're going to skip number 10. Turn the page, number 11. This is more so what your homework will look like. Grab your calculators. In your calculator, you have -2, parentheses 2, to the power, in parentheses, x plus 1, scroll over, -3. You're basically just typing what you see. You put your whole exponent, that x plus 1, in parentheses. All right, I'm going to try to match up. This is what our graph will look like. Okay? According to my graph here, what is my horizontal asymptote? Say it louder here. Good, -3. So I'm going to make my asymptote at, on my graph, you can't really see it, but at -3. Am I going away or am I going towards my asymptote? Away, so that will be growth. My domain, good. My range is a little different. I'm coming from the bottom, which is negative infinity, to my asymptote, which is -3. Normally we've had graphs above the asymptote, now it was below. My y-intercept, according to my points, just write in 0, -7. All right, this is what's new, kinda. Increasing interval. Look at this graph. Am I increasing or decreasing? You're decreasing the whole time, so am I increasing at all? No, so write none. So you're decreasing the entire time, which means you're decreasing from negative infinity to positive infinity. But you're increasing and decreasing, one of these will always be none and one will be negative infinity to positive infinity. The last part is your end behavior. This is your left arrow and this is your right arrow. If you look at your left arrow, I'm going to get closer and closer to my asymptote, which is what? -3. My right arrow is down here. I'm getting closer and closer to what? Negative infinity. Look at that, right on time. Are you guys good? Please do your homework. Set yourself a reminder to do it Monday night. Perfect timing because my battery's dying. But please do your homework. Your mini quiz is next class. Next class, we will go over it. Have a good weekend. Get out of here.